everyone. Today we discuss about the time independent Schördingers equation. Okay, so this for this we have to consider. So you have to consider a particle of mass m moving in positive x direction. Okay, so we have to consider a particle which having mass m and moving in positive x direction under a force f of x. Okay, then in this force field the potential energy of the particle v does not depends on time t, but depends on only the position x. let momentum of particle be p of x and total energy is E. Okay, so as we know that this is positive x direction, y direction and z direction. Suppose consider a particle. This is a particle which having mass m moving along positive x direction. Okay, under a force. So some force acts on this particle, that is denoted as f of x. In the force field, the potential energy of a particle denoted as v. This particle doesn't depends on time t, doesn't depends on time t, but depend on the position, that's the x, in which coordinates this particle is placed. Okay, so the wave function of the particle representing the wave plane wave associated with the particle. So we can write the wave function of the particle representing the plane wave which is associated with the particle h psi equals to a into e to the power minus I into et minus px into x divided by h cross, or we can write this h psi equals to a into e to the power I into px into x minus et divided by h cross. Okay, so we name this equation 1. Then we have to be partially differentiate equation 1 with respect to x, because we don't have to be differentiate partially to the equation 1 with respect to t, because we know that it doesn't depend on the time t. So after differentiating we get the result as dou psi by dou x equals to I px divided by h cross, and the similar rest of the part a into e I to the power I into px of x into x minus et divided by h cross. So we know that this is the similar part of equation 1, so we can write this as dou psi by dou x equals to I px by h cross into psi. or we can write px into psi is equals to minus ih cross into dou psi by dou x. So we can name this equation 2. Okay, from this, according to classical mechanics, we know that the total energy of a particle is given by E equals to px square by 2m plus v. That means this is the kinetic energy of the particle and this is the potential energy of the particle. Okay, so we can write this, and we have to be multiply psi on both sides, then we get E psi equals to px square by 2m plus v psi. Okay, now we have to be substituting the value of px. We get here E psi equals to 1 by 2m minus of ih cross to a whole square, then you get dou square psi by dou x square plus b psi. Okay, so after solving we also get minus h cross square divided by 2m into dou square psi by dou x square plus b psi. Here minus h plus, because the I part will be, we know the value of I equals to root of minus 1. When we square by I, that's minus 1. Okay, so this is our equation, which is dou square psi by dou x square plus 2m by h cross square into e minus v into psi equals to 0. So this is the time independent Schördingers equation. We can see this here. From here, there's no available of time, so we can call it time independent Schördingers equation. It is in one dimensional state. We can write it in three-dimensional h del square psi plus 2m by h cross square e minus v, that's e minus v into psi equals to 0. So this is in 3 dimension and this is in first dimension 1 dimension, this is 3 dimension. So guys, you can get this notes PDF also in the description below. So thank you for watching.